Okay, so this week there was only one, I'll say attendance quiz, and that was on Wednesday. So for this one, it said the question was find unit tangent vector to r of t equals e to the t cosine of t, e to the t sine of t. I think I just gave it in x and y, but I also meant to have a 0 here. So find the unit tangent vector to this function at t equals 0. Okay, so to find the tangent vector, not the unit tangent, but just the tangent vector, we take the derivative. So don't forget I need to use the product rule here and here, but I can simplify my life a little bit. I can write r of t is e to the t times cosine of t sine of t. So now if I do the derivative, I can just use basically the product rule, or something that looks just like it. So r prime of t, that's going to be e to the t, right, derivative of e to the t times this function, plus the derivative, or sorry, e to the t times the derivative of this vector function. Derivative of cosine is negative sine, cosine 0. Okay, so I could add these all together and start taking the norm of that, and then once I find the norm of that, divide by the norm, and then once I'm done with all of that, plug in 0. But if you remember, if you give me the value of t, this is going to be a vector, right? So I can just do r prime of 0, that's going to be e to the 0 is 1, cosine of 0 is 1, sine of 0 is 0, 0, that's 0, 1, 0. So the derivative of r at 0 is this vector. So that's the tangent vector. Now we want the unit tangent vector. So we can just normalize just that vector, right? So r prime of 0 divided by norm of r prime at 0, that's going to be 1 over root 2, right? Because that's the norm. 1 over root 2, 0. And if you did this with only two components, that's fine, but this was the answer I was looking for. And this is equal to the unit, so that's the tangent vector, the unit tangent vector at 0.